Okay, so for this video, we're going to be going over in a little bit more detail some of the things that are at the top of this common attribute, so not the specular shading stuff, which means it applies to the Lambert as well. Briefly, very briefly, obviously color, we've been using this the whole class. Pro tip, if you bring up different colors anywhere, and whether it's this specular color or whatever, and you go back to color, normally we've been double clicking to get like a real color picker. Um, but whether you double click or not, even single click, previously chosen colors for at least the last 10 will show up here. So this dark one is the ground. It was something I picked for the ground before I added a texture. These are different specular highlight colors I've been using, and then this is the color of the material. So if you make a new material, but you want them to be the same color, you can choose this. All right. And then of course, transparency is something we've been using all along. Makes it transparent. You can see it does not affect the transparency of the specular highlight. So if for some reason you wanted to, I don't know, animate that to make something fade away, which is not how you should do that, then you would have to also animate the specular highlight. So just something to keep in mind. Now, where I wanted to dig down a little bit is the difference between ambient color and incandescence, because it is a weird difference. It is not, it's a little tricky. So what we're going to do is I'm actually going to make a new material that is also a Lambert. I'm going to use my little color trick right here. So that way I know, let's see, we're going to call this one Incandescence, and then we're going to call this one Ambient, so that we know which one I'm playing with the ambient color and which one I'm playing with the incandescence. But essentially, back when we were using the Hypershade more often, you all probably remember that you'd pick a color and it'd look like this, and then you go out into the scene and it would not look like that. So if I go to so my two Lamberts, they do look identical right now because they are. That's not even remotely what those look like. But they would be much darker. You know, they would be, even if I changed the color in here to something brighter, there we go, they would be darker. And we were all like, oh, well, why is that? And that's in large part because the lighting. So if I go to this one here and I turn up ambient color, what this does is it turns it closer to the actual color. So turning up ambient color all the way says, irrespective of lighting, you will look this much more like the actual color that was chosen, right? So this is the bright color that was chosen for this one as well. Even in the direct light, it's not as bright, right? So ambient color, now it flattens it out. It turned this into one flat little shape. Right, when we do that, and we've seen it happen in other ones, where if we turn up the ambient color all the way, it can get rid of, except for the highlights, it's getting rid of almost everything. So that's what ambient color does. Incandescent can look very similar, except it goes way beyond that. Right, so incandescent makes something look like it's emitting light. It's not emitting light. It's not going to shine light on anything, but it can make things look like a little bit glowy. All right, so this changes how, as if there's light coming from everywhere at the object. This makes it so that it looks like it is emitting light. And recommendations I have seen time and again, although definitely not on that, is that a little bit of incandescence can make something, can work well for foliage. So if we look at these that have a little bit of shiny on them, I'm gonna make this one also be a regular Fong, just so they could be identical. Oh no, I can't. Existing material, no, new material. In order to compare and contrast, I need to have two different ones, obviously. There it is. So I've made this one a little bit incandescent, and this one isn't. And the result is that this looks a little bit waxy. So that's one of the reasons to do that. Is it's not about the fact that leaves glow or anything, although they do kind of have a lot of light showing through them. But it can also make them look a little bit waxy, which is how some of these things look. I've also seen people mention using it for lava, stuff like that. All right, but this is, let me undo a little bit of my mess here. There it is. So ambient light, all the light that's coming at it, it's basically saying, nope, you're lit up brightly. Whereas incandescence is like as if it's giving off its own light. There's going to be a separate video on bump mapping, so we're not going to worry about that here. But basically, that can make it look like there's stuff on the surface, different from the anisotropic, which is pretending there's bumps on the surface, but we don't, and so the light catches it, but we don't actually see them. The bump map's a little bit different. Diffuse. So diffuse, which I'm gonna also use with this, changes how the light gets diffused along the surface. And we've also seen there's a setting on the lights that have this. But this is another way to kind of make something look more like its color. So I change this to be this color. And then if I change its diffuse, well, I turn it down. Oh, I turn it down too much. Let me turn that up just a little. You can see there's like a little, there it is. The directional light hits this, but doesn't really do that much. Whereas if I start to turn it up, more and more light hitting the surface until if I turn it all the way up, the parts where the light is hitting it, it's saying, no, you're going to be exactly that color. Now, you'll notice the diffuse is usually set kind of high. Yeah, it's set to 80%. Because in real life, light diffuses all over the place. And this is a good way to kind of get that right away. If you were to turn that down everywhere, things become a black hole, right? And that's not how really anything works in physics. Now, if you want to make something look very, very matte, you can start to turn this diffuse down a little bit, which does make no sense on some of these specular kind of things. But it's a subtle change on anything with a specular. So if we turn this all the way up, it's almost like there's more of a contrast with this edge to over here too. If we turn it down, now the highlight almost like counts for more. This almost also starts to look like nighttime lighting because we're getting rid of the color, but the specular highlight's still there. So the light is reflecting off an item, but we're not getting enough light to really see the item. So yeah, there's a few different ways you can use this, but generally speaking, we do tend to leave this turned pretty high up because, again, that's how life works. All right, so in order to go over translucence, I've done a couple things. So this is our control. It's a blend. It's not going to have any translucence changes. These two are the same material right here. I'm going to make changes to this one while it's selected so we can see what's happening here, because this is another one of those subtle things, and I want it to kind of be more visible. But we use the word translucence incorrectly in real life sometimes compared to this, where it's like semi-transparent. That's not what it's really meaning. Translucent in this case is some light that gets a little bit below the surface and then gets bounced around. So diffuse is light that gets bounced around like literally on the surface, and then translucence is it kind of went underneath a little bit first. So something that's kind of glassy, for example. So when I turn translucence up, if I turn it up all the way, it flattens out. Now you can actually turn the diffuse down a little bit to unwash it out. I can also not have translucence up all the way, but then I can also, there's a depth and a focus on here. Depth is about how far the light goes down before it gets bounced around, and then focus is how much the light gets bounced around. There we go. So we can see it's not focused anywhere, meaning it's extremely all over the place. And then we can kind of use that to focus it as opposed to depth, which depending on my settings, we may not even see any change. Oh, there we go. I mean, if you turn it all the way down, there's parts where it doesn't get to. Ah, here we go. We can maybe start to see. Nope. I think part of my problem is I also chose a very dark color. But yeah, if we turn up the focus, turn down the diffuse a little bit so it's not so washed out. And also, if I was doing something like this, frankly, I would be changing the specular color as well, because that shouldn't be, there we go. If something has translucence to it, it probably wouldn't have this bright white, highlight on it. All right. This is probably something actually that would work better on flatter objects. It would probably make more sense to have on a flatter object, where if you have like leaves and stuff, because you can also make it semi-transparent. There we are. And so it also, a little bit of what's going on is what I have this working on is not necessarily what you would be applying it to. There we go. That's way too transparent. A little bit goes a long way on transparency. Like a very little bit goes a long way. All right, so that's translucence, and that is the last thing that should be let me double check and make sure, turn everything back on. Yes, so that's the last thing that applies to all of the types of stuff, including actually a Lambert. So you can have translucence turned on for a Lambert. It will be a little bit different. And same with anisotropic. So regardless of the material type, if you're working with a standard material, you will have these settings available to you. And I wish I could be like, yes, use this for this type of material, but honestly, a lot of this is trial and error. A lot of it is going to come down to the specular highlight, which is going to be a different video. And there's tons and tons of things out there about the different types. Autodesk themselves recommends Fong for glassy surfaces and Blend for metal. I can't say that I blame them. It kind of makes a lot of sense, especially when you look at how this one looks. That's starting to look like metal, right? So, and then anisotropic is, I would definitely say, is for things that would have grooves on them. So you have to know not just that it's like metal or plastic, but like what kind of metal or plastic. I said CDs for a reason. If you make a CD, you make it with an anisotropic material, which actually, if I make this one flat, this flat one here, anisotropic, and I change the angle. Oh, it's not catching any light. There it is. Look at that. This is why something like a CD should be anisotropic. Roughness, there we go. All right, so that is it for the common attributes. You can look to the other video for the common specular shading attributes.